Thank you so much, and thank you for your patience. My name is Pat Oker, and it is my great privilege to serve as Dean of the College of Arts and Science here at Mizzou. This really is a wonderful day. Thank you so much for coming. It is just so wonderful to see so many of you here today. As you all know, this is a press conference, but you all know what the news is. We're here to celebrate that Professor George P. Smith, a Curator's Distinguished Professor Emeritus of Biological Sciences in the College of Arts and Science here at Mizzou, has been awarded the 2018 Nobel Prize in Chemistry. We're going to clap. And I have to say, when I woke up this morning, I had no idea I was going to say those words. So what a delight. He shares that honor with Francis H. Arnold at Caltech and Gregory Winter from the MRC Laboratory of Molecular Biology in England. And on behalf of the entire campus, I want to extend our congratulations to them as well. Of course, our opportunity today is, of course, to focus on Dr. Smith. And on behalf of the college and the campus, I want to extend our very hearty congratulations to him for this very amazing accomplishment. And I'm going to turn the mic over to the Chancellor in just a minute, but I want to say a few things about what I think this award means to Mizzou, what it means about who we are and what we are as an institution. This award, in my opinion, celebrates and validates the impact of basic research, particularly research that is interdisciplinary in its focus. So as many of you now know, I'm sure you've been reading the details about his work. Dr. Smith is trained as an immunologist and in molecular biology, and he's a curious researcher, as all good researchers are, I think. And one of the questions he asked was, what would happen if we apply the principles of evolution to the fields of immunology and molecular biology? And what he came up with in terms of an answer, of course, is a method called phage display, the applications of which are far greater than any one person could have ever imagined. This is what we do at Mizzou and in the College of Arts and Science. We do basic research here at Mizzou. We ask essential questions about how the world works. And in his case, it's about peptides and antibodies, but we ask essential questions all across campus. And then we apply that basic research to all kinds of real-world problems. And we have researchers like Dr. Smith. And of course, he is the wonderful example of this, of how his work, in ways that even he could not have imagined when he first started this work decades ago, about how this work benefits all of humankind. And so we see in the impact of his work, the applications include vaccines for diseases like malaria, improved treatments for cancer and autoimmune diseases. And even I just discovered today, helps discover stress fractures in steel. I'm certain he did not imagine all of those applications when he first launched this work. And for Mizzou, this is a wonderful way of celebrating the time that he has put in, literally decades of work on this research, and also the investment that Mizzou makes in basic research. And it is my delight to celebrate that achievement here. I want to tell you one other thing about what I think this award means both for Dr. Smith and for Mizzou, is that shortly after the award was announced, and there was a smaller reception in Tucker Hall in the Division of Biological Sciences, and he showed up as a good celebrity does on one of the golf carts and got out. One of his colleagues approached him and said with great enthusiasm, she teaches a general genetics class, she said, "We were just talking about phage display," and they had this spirited conversation, and within less than 2 minutes, they had a plan so that he could visit her class later on this afternoon. So sometime this morning, between the announcement and now, I have no idea how many reporters. He also visited a general genetics class. What that means is students here at Mizzou, This, I say, is what we do at Mizzou. We make sure that our students, our undergraduate students and our graduate students have access, direct access, on the day they win the Nobel Prize. I mean, you can't script that any better. So, Dr. Smith, congratulations on behalf of the College of Arts and Science. Thank you for being curious about the world. Thank you for decades of work. And thank you for sharing that passion for your field with the students at Mizzou. And with that, it is my great pleasure to turn this over to Chancellor Cartwright.
Thank you, Dean Oker. It really is a pleasure to be here. I just got off the plane after a full day of flying back from Thailand, so I'm still not asleep yet. But it really is great to come back to this. It makes you not want to sleep at all. So maybe I'll be up all night again. But it really is a tremendous event to be here, to see all of you show up for this important event. I want to thank all of the people who have supported us with this. I want to thank some of the curators, the legislators, governor, the president of the system, all who are probably watching on live stream, but also who have called and really conveyed their enthusiastic support of and congratulations to Professor Smith. It really is an amazing opportunity. So I'd like to get started with just one thing to show that real pride for who we are. M-I-Z. C-O-U. That was very good. Good. Dean Oker said something that is really important, and in a little bit of the conversation that I had with Professor Smith coming over here, it became just as important. He echoed the same thoughts, and that is that our job here is to give people the opportunity to work on new ideas, to think about what they are interested in, and we don't know where some of that basic science will lead us when we start it. And that's what this school is about. That is what the College of Arts and Science is about. That's what Dean Oker is trying to put in place and continuing to put in place in the college for all of the things that we want to see coming out of our basic research. So thank you to the college. Thank you to the biology department, everybody who supports this. It takes that group of people to make all of this possible. So thank you to everybody. It's certainly always easy to wear black and gold, but no day easier than today, when we have one of our own, Dr. George Smith, received the Nobel Prize. And that is a remarkable thing. So thank you. I also want to echo some of Dean Oker's comments, and that is, Dr. Smith worked on many of these things for a number of years. He's had a 40-year career here at Mizzou. And I'll let him explain how all of this happened, because I really don't completely understand it. But so we'll let an expert talk about it, a Nobel Prize winner talk about it. But this reflects on what happens at an institution, and that is that it's hard work. It's those ethics of Mizzou. It is what we do. It is working with our students, sacrificing to be able to work on topics that we are interested in, that sometimes people may question where it's all leading. But it's with breakthroughs like these that you see what can come out of it. It really is, it's impossible to overstate the value of his work on cancer treatment, the development of vaccines, stress fractures in steel, and so much more. As I'm sure many of you know, today's honor comes from Dr. Smith's development of phage display, and specifically his research focused on producing new antibodies used to cure metastatic cancer and to counteract autoimmune disease. And today, drugs based on Dr. Smith's research are used to treat conditions like rheumatoid arthritis and psoriasis. It is incredible to think that work done in our labs here on our campus have a direct impact like this on the quality of the life of all individuals around the world. Today is a great reminder of the incredible work that our faculty do here at Missouri's flagship university. I look forward to seeing who among you will be the next person whose accomplishments we will celebrate like we are today. And I look forward to that in the near future, I hope. But now I really want Dr. Smith. It's interesting when I was talking to him that it wasn't possible without a lot of other people who worked with him, who came before you, who set up, you built on other people's work, and people who worked alongside you. But I really want you to know how grateful we are that we look at what you did for science and also for Mizzou. It is a remarkable achievement, one that you should be proud of. And I know from just the brief interactions with you that, you're somewhat humble. and I really appreciate that, because it's wonderful to see a remarkable scientist who understands that it's about the work that you're doing to move society forward. And that is what he devoted his career to. And so, without further ado, I'd like to introduce Mizzou's Nobel Prize winner, George Smith.
My first standing ovation at Mizzou. It's always a first. So in case you're having trouble, to recognize the Nobel laureates, the one that's not in the suit. And I should warn you, I was 40 years a professor here, so when I see people lined up in rows in front of me, I'm triggered to give a lecture, so be prepared. I don't know if I really want to say that I'm particularly proud personally of this award, because as I think probably all Nobel laureates understand, they are in the middle of a huge web of science, of influences, of ideas, of research, of results and stuff that impinge on them and that emanate from them. So phage display was a discovery of a technique that first had been discovered by other people in other contexts. Secondly, that absolutely depended on lines of work that had gone before. I happened to be in the right place at the right time to put those things together. And I think also partly as a result of the fact that I didn't succeed in patenting this, that it was open science, I think it has been very, very influential in ways that I absolutely could not have anticipated. So let me just say that many of the medical breakthroughs that were mentioned are really not due to me at all. They're due to one of the other winners, Greg Winter. Those therapeutic antibodies were set in place by the work in his lab and work that came earlier in his lab. So this is a, I don't know, I'm getting an honor that has been earned by a whole bunch of other people. And if we think of science as a web of influence and so on, a web of science, and one particular person is in the middle, it's not a, that particular person can't take full credit for it. You just have to realize that that person is a stand-in, is a representative of a whole field of knowledge. And another thing that I think that follows from that, that the Chancellor mentioned, is that no way you could predict in advance that this would be something really important. Certainly, I didn't, and the people, all the people in my lab that were working on this didn't realize it was something, for example, that was going to lead to medicines. I guess we were pleased that that was so. But it just means that science doesn't work by picking winners and deciding that this is the way, the person that's going to make a big breakthrough or make a lot of money or whatever. That's not how science works. Science is a big community of people that are engaged in their work and in their teaching. That's really important as well, and that's really vital in a broad-based. I think we call it a flagship university like the University of Missouri, just has to keep that in mind. We have to nurture a whole big community and not decide that we have to do our best to pick people that get prizes or people that get big awards. That's one thing I'd like to say. So I think that the University of Missouri has been really good in this respect. I mean, a researcher like me who has only published 50 papers or so since I've been here, that's not a big output, has taken a number of tacks of research and of interest. Someone like me can flourish at Mizzou, and I think that's something that Mizzou should be proud of. That Mizzou should be proud of nurturing that kind of intellectual community. And I would like to make the point also that it's any subject that is intellectually engaging, it's interesting, engages people. And I'm a STEM person, science, technology, engineering, and mathematics. I'm really interested in and use mathematics, and I'm a biologist, and I know a little bit about chemistry and stuff, so I'm definitely STEM. But STEM is not all there is to this university. This is a university, and that whole thing of a web of knowledge, not just a web of science, really applies to the university as a whole. Okay, so we have another 50 minutes of this lecture, so I can explain. Anyways, could I have the first slide? Okay, so I think that I've said enough. I mean, if you want to, anyone wants to talk about the details of phage display, I'm glad to do that.
For the media that are here, we did promise that we have an opportunity to ask some questions, and we're going to take questions for the next 15 to 20 minutes. Rocky, you want to go first? Please do me a favor for all the media that are here. Speak very loudly. We have individuals on the phone that are listening, and give us your name and the affiliate that you're with when you ask your question. Thank you. Rocky?
Yeah, I'm Rocky Madden from Channel 2 and Channel 11 in St. Louis, Missouri. Question: I heard on NPR you thought you were being pranked possibly. And second of all, what's it like as a university as far as putting together? We've done so much for people who are suffering these illnesses, medical problems. Be a part of it.
Okay, first question is, like a standard prank in science is, your friends take on a fake Swedish accent and call you up at 4:30 in the morning and say, "This is the Swedish Academy of Science. You won." Who would fall for that? But actually, I kind of knew it wasn't any of my friends because the connection was so terrible. I mean, Sweden is a really advanced country, but I think that they need some work on their phones. Well, So the second thing, am I proud of having cured a whole bunch of people? You know what? You should ask one of my co-winners, Greg Winter, and his lab, like hundreds of people in that lab from the 60s to the present who are way more responsible than me for that. But it has, so they won the Nobel Prize for me, and they got it themselves as well. I think that's good, but I didn't do that. I put forth a technology that could be applied to that. And believe me, if I was not smart enough to anticipate what would come out of this research, I had a much narrower view than I have now. And I was rapidly educated by a whole bunch of very smart people that, you know what, this can be you can do this and this and this that I didn't realize.
Other questions? Great.
Hello, with the Columbia Daily Review. I think I asked you this earlier today, but maybe it could help people around here. I said, can you explain this to idiots in 2-syllable words? Because I'm an idiot.
Okay. Well, welcome to the club. All right, so you really want to have some idea what this is about. Okay, so an example that I brought up to you is that let's say you want to design something that can fly and also suck nectar from flowers. So an engineer would go about it by using his or her engineering knowledge, physics and material science and so on, and design the wings and stuff, and also a tube or something that could suck the nectar out of the flower. But of course, that's not how insects evolved. They didn't evolve in that way at all, because nature is not an engineer. Nature doesn't have a clue about how to design anything. Instead, we had this huge collection of living things, and they were all in an environment, and a few of them developed variations that allowed them to do something that gave them a slight advantage and allowed them to proliferate more than their neighbors. And this little steps, one at a time, can lead to the evolution of very incredibly complicated machines like a bee or a butterfly. So phage display is a little bit like trying to put that kind of idea, that kind of evolution by natural selection in a test tube, very much simplify it. And also, and this is important, not let nature's natural selection create the pressure on survival, but you, the experimenter, decides. So if you can't design a fly yourself, if you can create a system that where things that happen to be have fly-like characteristics proliferate, then that's the thing. Even if you haven't a clue how to design a fly. Phage display is a little bit like that. It's much simpler than a fly, way simpler, okay? But it's a test tube where you have a large number of things, entities competing with each other. They happen to be phage particles, that is bacterial virus particles with foreign proteins displayed on them, attached to them. You have this huge biosphere of phages, so it's a really simple biosphere. And you artificially impose a selection on them to favor those things that you want. A new drug for arthritis or whatever. That in a very abstract way is what phage display is about, and many other technologies, not only phage display.
You got a question from the Missourian? Begin your name.
Well, as I've said several times today, It would have made a big difference if I'd gotten this like 10 years ago. My division chairman would be very pleased because I have all these successful grant proposals rather than these excellently written but unsuccessful grant proposals. That would have changed a lot. I don't think it's going to change my life now. I'm retired. I'm really not doing much science, although I'm an honorary member of Pam Brown's lab there. They're over there en masse. And I do go to some other some lectures and some lab meetings. So I'm still peripherally connected, but I don't think it'll make a lot of difference to me now. But I don't know. Who knows? Probably get a lot of invitations to go make talks at places, and I will have to be very careful about which ones I accept.
Rocky? You're going to get apparently $250,000 cost you for that.
I don't know. Do you? Is that why you're asking the question? No, we're going to donate it to something, but we absolutely haven't. The family will get together and we'll try to come up with something to give it to that would benefit from the honored by the indirectly like this way by the Nobel Prize. So we will try to figure something, but we haven't decided that. We haven't discussed it yet.
I have a paper coming up all funding published. Can I ask you
Stephen and I have a couple, I think 2 papers in common. Yeah.
Do we have other questions from the media that are here? Yeah.
Yes, I think it has. But I had a day for that to sink in. Oh, that's a good question. The question was, how will this prize further MU's research mission? And actually, I tried to say that I think it's not just narrowly conceived research mission. I think it's overall mission. But yes, I think like an honor like this, I think redounds to the university. Let's hope that the hard times that we have lived through for the last couple of years will be a little less hard times. That's what I hope. And I hope the University of Missouri will continue to foster academic enterprise, whether it's STEM or not, whether it's STEM or social science or art or literature. All of these things are just such a vital part of a real living university.
Let's go to the phone now. For media that are on the phone, do you have any questions? And please remember to unmute yourself if you're trying to talk. Murray, do you have any questions? Or I know there was a gentleman from science on the phone.
Hello?
Yes, Murray.
Yes, it is. Murray Williams from the Star. I was just curious. I mean, you were at MU for 40 years, but how long? How much time have you spent on this particular science? How long have you worked on this particular science?
Well, that's a good question, and the answer is not that long. That is specifically on phage display. It started in 1985. in 1984, when I was on sabbatical in Bob Webster's lab at Duke University, and continued when I got back here. And I would say by the mid-1990s, basically our contribution to the technology was over, and many other people were taking over the many different applications and variations on that theme. So it was a period of less than 10 years. I then began to focus pretty specifically on developing new approaches to vaccines for difficult diseases, especially malaria. I would say that my career was not that successful in that endeavor. That explains all those unfunded NIH grants, I guess. That consumed me a lot more than specifically phage display. Although I talked to people about it and gave advice and so on, some of which was good advice and some of which wasn't good advice. Like I had a colleague, Valerie Petrenko, who was doing phage display in Russia. I had never talked to him. He sort of like read the paper, and he did a version of it that I would have absolutely counseled against. This isn't going to work, Valerie, but he did it. There were other people involved as well. But I myself really wasn't focused specifically on phage display for more than about 10 years.
Other questions?
Thank you.
Murray or others? Any other questions?
Yeah, I did have one question, actually. I was curious about how when you were talking about initially science as a web of ideas and you're in the right place at the right time. Can you talk a little bit about what you saw as your inspiration that really sort of led to your adoption?
Are you from science? Where? Sorry?
Yes, I am.
Oh, okay. All right. So I can't name all the influences. One is that the particular kind of phage that I worked on, which filamentous phage, had a long, decades-long background of research, of really clever research. So I benefited from a lot of knowledge of the physiology of this phage, and I began to work on the physiology myself. So that was one really big influence. A second influence was that I would point to particularly was in immunology. People were developing methods that are just like this test tube evolution, but not using using chemistry rather than biology. So there was a whole field of developing ways of searching through huge libraries of random peptides, of short random peptides, for peptides that would have some particular activity, binding to a particular antibody, for example. And I was very influenced by that. At the same time, in molecular biology, people were developing experiments where so-called degenerate DNA molecules were made. This is DNA molecules where at each position, all 4 nucleotides were added. So that at the first position, you had 4 possibilities. After the second position, you had 4 times 4, 16 possibilities, etc. So these were degenerate DNA sequences. And that was really vital in the practical way of creating huge peptide or protein libraries in phage. I think I want to name another influence, which really is represented by Greg Winter's prize. So the laboratory from the 50s, really from certainly early 60s, the laboratory of César Milstein, eventually joined by Georges Köhler, were working on the immune system, and they had a vision of what they called cloning the immune system. That is, getting the essential elements of the immune system to work in the test tube rather than in the living body. So I was extremely influenced by that work as well. And they were doing this kind of work well before phage display, and they immediately understood that phage display could really further the idea of cloning the immune system, of getting the immune system to work in the test tube rather than requiring that it work in the living body. That's what I would name as my main influences.
I think we have time for one or two more questions. Is there anybody else on the phone that wants to ask a question? Okay.
Hi.
Go ahead.
Ken Chang from the New York Times.
Hi.
What problem were you trying to solve with this? It's a very clever way to connect the gene with protein. And how did you realize this would be a clever way to solve a particular problem?
That's a really good question, and I would say that my vision at the time, my field of purview was pretty narrow, because I was specifically looking for an easy way, a much easier way to search through big libraries of proteins or peptides that would bind an antibody. And this was a standard kind of process in molecular biology at the time, in the late 70s, early 80s. And but it was very tedious, because every possible peptide was coded by a phage, but not displayed on the phage. Every possible peptide really had to be searched through one at a time. So it was pretty hard to get up to 1 million. But really hard. Not impossible. It was done. It was done, actually. And some Nobel Prize work was done in this way. But phage display would allow you, instead of having to look one clone at a time to find the one you want, phage display would allow you to create huge libraries of clones with 10 billion, 100 billion structures in it. And instead of having to search through them once at a time, you develop a way of selecting, that is, physically pulling out the ones you want so that you can throw away all the others.
Makes this clear. So, I'm not having like a long conversation with my mom or that's why I'm not talking right with my mom.
We're catching up. We're catching on some extra conversation here. Can you make sure your line's muted?
Oh, sorry.
Were you done with your answer? Or are you good?
I didn't get another question. I'm done with that answer. And it's really hard to unmute me.
I think we'll take one more question from the media here. Is there anybody else that has one final question from the media here? Anybody? No? Anyone on the phone? One final question? Okay, I think we're good. I'm going to turn it back over to Dean Oakley.
Thank you, Dr. Smith, for spending some time with us today on this very busy day. I have to say, and as I look around the room, I see scientists, many young scientists. I also see people in the arts and humanities and the social and behavioral sciences from all the different schools and colleges. And I am absolutely certain that your commitment to scholarly excellence, your humility, is both a wonderful testament of what we aspire to here at Mizzou and will also inspire every one of us today. So thank you so much. Do you have any final words for us? He does.
Yeah. I would just like to say one more thing. M-I-Z!